Recording, excellent. All right, everyone can see, right? So SQL, we've been kind of hinting at this for weeks and weeks and weeks. SQL stands for Structured Query Language, and it is a formal language that we're going to use to interact with databases. The first question is, what is a database? Does anyone have any ideas other than Selena, who's in a database class right now? Gregory, go ahead. What's a database, Gregory?
A database is a Nobi. Well, there's two types. The Nobi, it could be a warehouse or a server. Database mostly contain information of the company or data that reserves like inventory or actual like data information from different customer accounts, IDs. If you work with like a military, seeing who come in, come out,
Yeah.
or
So you described a bunch of uses of why we would use a database, but at its core, right, a database is just a place to store data, right? So the very earliest databases, and we could have built this week or last week when we were learning about the file system, is we could just write to a file, right? We could say, here's my data, put it in this file, and then when I need the data back, I'm going to read from it. That's a database. It's not a good one, but it's a database, right? A database is where we store our data and retrieve it for later use. Another great example of a database that we've been using already is local storage, right? So local storage is a great example of a database where we're taking our whatever records that we want to have and we're storing it in the browser. We're telling the browser, hey, when I set item and I give it a key of users, right? This is the user's record. That is a database. Now, why do we need one, right? And the answer, hopefully, is obvious at this point, which is we need a place to put our data. We need a place to, if we're going to build a website like a portfolio page, we don't need a database for that. But we do need a database anytime we want to do anything more complicated with our products, with our websites, with our apps. Gregory gave a bunch of great examples, like a warehouse, right? You want to track all of your inventory, right? You're going to need some place to store all that data. Now, way back in the 70s, before we had actual really good database servers and before we had SQL, the old way is you'd write the information to a file, and then when you needed to access it, you would read back from that file and loop through all the rows in the file and find the one that you wanted, and then make a change and write it back to the file, right? At its core, even the databases that we're going to talk about today, they're actually doing that. They just have a mechanism for storing the data on the file system, and then they provide an interface to us, and that interface is SQL that lets us read and interact with that data. Okay. There's a couple different types. The main thing that we're going to focus on this class, we've already looked at non-relational databases, and the example of that would be like a file system, or local storage is a perfect example of this, where we're saying, here's a JSON object, and I'm just going to shove it here and then retrieve it back. That's non-relational. But we're really going to dive in this week and focus on relational databases. And this is a really complicated concept for a lot of people, because we're expressing ourselves. It's kind of like classes in JavaScript, where we're expressing real-world concepts in a definition that lets us retrieve and interact with that data. And we do that in a relational database by setting up relationships between one record and another. Okay? So maybe now's a good time for examples, right? So think of this spreadsheet as a relational database. So each one of these little tabs here is its own table. And so let's just pretend that this is the users database, right? I'll just make this users, right? And the users is going to have a couple columns. So we'll say ID, first name, last name, email address, right? And so it'll be like, and so these are the columns, right? And you're going to use these same terms when we learn about the database tables themselves, right? They're going to have tables, and they're going to have columns in those tables, and then each record in the database is going to be referred to as a row, right? So each row that comes down here, user ID 1, Eric, Harrison. Yes, go ahead, Selena. You're muted.
Did you want me to share my screen and then show the MySQL thing?
We're gonna do that later today.
Okay.
Yeah, we're gonna get to that. I'm just trying to give them. It's easier to see in a spreadsheet because it's very similar. Like one of the earliest databases that most people may have gotten exposed to way back in the 90s would be Microsoft Access, which is like a lightweight personal database, but it still has SQL beneath the scenes. So ERH at the clubhouse, right? So this is one record, one row, right? User ID 1 has a first name Eric and a last name Harrison and has this email address. User ID 2 might be Leah Neville, right? Is that your last name? Is that how you spell it? Whatever.
Yeah, that's right.
Leah, cool name, right? And then, you have some email address, leah@gmail.com or something, right? So these are 2 records, right? When we're working with databases, we can insert as many records as we want. And so when you're working in the real world, right, you're going to have tables that have thousands and thousands of records in them. And you're almost always, when you're building a table, when you're building a database, you're going to have a single column that is generally going to be referred to as the primary key, okay? And so that's, user ID 1 is Eric, user ID 2 is Leah, and so on and so forth. But this really also, in the context of relational databases, sets us up so that we can join related information together. So if we had users here, and then maybe we have another table, and we'll make a new spreadsheet here, and we say, this is like posts, right? So maybe this is a blog. And so it will have an ID of itself, and maybe you can think of this as like post ID, right? And then user ID, and then title, comment. Okay? And so post ID 1 was posted by user ID 1, which is Eric, and the title was hello world, and the comment was hi. And then post ID 2 was posted by user ID 2, and it says hi Eric, right? She's responding to me now. So we're setting up a relationship here between the posts table and the users table, right? There is only one user per user, right? Like when you're thinking of modeling data, you're thinking in terms of like the real world representation of our information, right? If you've got a whole bunch of users, right, there can only be one user that, like, the user is unique, right? And so Eric Harrison might do a bunch of things in my product that I want to reference to his user account. And so we would do that by setting up these relationships. This is really the thing that sets relational databases like MySQL or SQL Server or Oracle or Postgres. Those are all relational databases, and they all operate on this exact same model, where you've got tables that have columns, and those columns have rows in them, and the rows let us connect to other tables, usually by an ID or a foreign key relationship. So this user ID column in the users table, in the post table, links to the users table over here, and we'll show you how to do that. Okay, so kind of everyone makes sense. So it's really helpful. This is one of the ways that I've always kind of maintained this picture in my head. Is I like to think of this as spreadsheets, right? It's you've got columns exactly like this. You've got a whole bunch of records inside of here. Any number of records can exist in here, and each individual spreadsheet in the document is its own source of information. So you're only ever going to want to have one type of information per table. Okay, we could just as easily have made a really ugly, like if we didn't have a users table, for example, but we needed to know the name and the email address of the people making the post, we could have come in here and said, username, user last name, and user email, right? And we could have attached that information in this table itself, and store those records. But then what you'll see is, Eric Harrison, ERH at Clubhouse, right? As I continue posting, right, you can imagine I keep making comments on this in this blog, right? So 3, 4, 5, right? I'm duplicating this data over and over and over again. So we don't want to do that. We want to store this data that is, associated to this information, right? The post itself is unique, right? That's why we were storing it in the post table. But anything that is specific to the person doing the posting, we want to put in its own table so that we're not creating extra records in our database, right? So if I wanted to change my username in this model, I would have to update every record and say, I actually want to be called by my nickname, Ryan, right? We'd have to update each and every record in here to have those changes be reflected. Whereas with the relational model, where we've got separate tables for this, I just have to update my first name in one spot, and then every other part of our product automatically knows that information has changed. This is the power of relational databases and what makes it so just incredible to work with. Being good at databases in development is what is going to take you to the next level and make it so that your products actually have life and have purpose. Andrew's app is a great example of this, where he's building this golf tracking app. Being able to store those records in a database so that he can then go back and see, the last time you played on this course on shot 2, you always shank it into the woods, right? Like, you need to approach this differently. That is possible because of databases. Now, that's relational. So whenever you think of relational, think of, in your head, picture a spreadsheet with a bunch of different sheets on the thing. Non-relational databases are like the ones we've been playing with up till now, like local storage, where we're just going to say, hey, take this JSON blob and shove it in this record, and then give me that JSON back. That is non-relational. Any relationships we want to set up between a user object and another user object or another record, we have to do that ourselves. Relational databases have this by default. They understand these types of relationships and they can join things together. But when you use non-relational databases, you're responsible for doing those joinings yourself. Now, why would you want to use a non-relational database? This became a very popular thing recently, actually, with the rise of JavaScript as a back-end programming language. JSON itself is a beautiful object representation. We've been using it up until now, using it in things like local storage. It's really easy to say, like, here's my user object, just shove it in a record for me. Let me get it later. So we see databases like MongoDB is probably the most popular of these, where it's a database and it gives you some limited database retrieval capabilities, like you can find records by name or by key or by value, but you're storing it as a JSON object instead of as a row or a record. So, the trade-off here is that you lose a little bit of the expression that you get from being able to set up relationships between tables and between records and tables, but you get the speed of just shoving JavaScript objects into a place and knowing you can get it back later. Okay, so neither is good or bad. They both have trade-offs, and we'll maybe continue to explore later this week. We might take a look at some of these non-relational databases like Mongo or Redis. Some of these databases have very specific real-world purposes that are extremely useful. MySQL or some of these SQL-based databases are slow when you're dealing with millions of records, whereas a non-relational database where you're just saying, give me record 5, and it gives you back an entire user object, some of those are blazingly fast, and you'll use them as a caching layer if you're deploying a website for the internet to use as a whole. All right, so we're going to learn MySQL in this class. MySQL is a great, free, open source database that has been around for 20 plus years now. It's extremely well tested. You're going to see this in, I'm just going to make a number off the top of my head, but this is probably like 30% of all databases in use in the world are probably MySQL. All right, it's a staggeringly high number, specifically because A, it's free, B, it's been around forever, and C, it's like very well supported by every programming language that you'll ever need to use, right? So we're going to use Node.js, we're going to continue using JavaScript here, but in PHP, Perl, Python, C++, it's very easy to make queries to MySQL databases. You might also, a couple of years back, the original license holder of the MySQL system was purchased by Oracle. Well, it was purchased by Sun and then Oracle. And so because it was open source, a group split off and took the source code of MySQL and created a new database called Maria. Okay, Maria and MySQL are functionally identical, except Maria is being developed by a different team now. So when you sometimes use Amazon Web Services or some of these other places, they'll give you a Maria database. It's MySQL behind the scenes. Microsoft has their own version of a SQL Server, MS SQL Server. So if you're working in a Windows environment, you might use this. Postgres is another competitor. It's like a direct competitor to Maria and MySQL, in that it's another open source database. And then SQLite is a really good database for doing quick development. So sometimes you'll see that, but it's not really intended for if you're building an app for the entire internet to use. You're probably never going to use SQLite for that. It's just really a prototyping database. And then MongoDB, we'll try to look at that this week. This is the non-relational database we were talking about. The good thing about all these SQL-based servers, Oracle is one of these as well, is that they all use structured query language to describe and interact with the data. So we're going to learn SQL primarily because if you learn SQL, then it doesn't matter what database you're in, with the exception of MongoDB. They're all going to let you interact with the data in the same way. Any questions about this? This is just kind of like a high-level overview of the databases. No? All right. So at its core, all these databases kind of operate in the same way, right? You're going to have a server, right? We've been building Express as a server, to be our web server. All of these databases exist. They're going to listen for connections. They're going to use TCP, which is the Transmission Control Protocol, to communicate over the internet so that we can connect to a database, make our query, and the database will return our information back to us. They're almost all going to function as a server, with the possible exception of maybe like SQLite or some of these other ones. And they consist of databases. So at its top level, right, when you connect to the server, you're going to first select what database you're going to be operating out of. Okay. Inside the database is tables, right? So when we're looking at this, you can think of this entire spreadsheet as the database, right? The database contains tables, and the tables contain columns and rows. Okay, so from big to small, database, table, columns, and then the rows themselves of the data. Okay, and then as we kind of showed off, tables can relate to each other with keys, right? So in this example, right, the post table has a key that links to the user ID, the ID field of the users table, and so we're going to be able to query back and forth and share data amongst tables using SQL. And the individual items in here, right? Like this, you're going to hear it referred to as either a field or a cell. I almost always just call this like the record that you're retrieving. But those are some words you need to be aware of because they're going to come up time and time again. What is that cell value? What does that field say, right? And then when we're talking about SQL, you're often going to hear the acronym CRUD, which stands for create, read, update, and delete. Those are the 4 operations that you're going to be doing with a database on time to time: creating a record, reading the record back to us, updating the record, either changing some information or deleting it. Right? Those are the 4 operations, and we're going to learn those in SQL here pretty quick. All right. When we're talking about SQL, the reason we define our columns like this is because each column contains specific types of data, right? So this column, all these columns, for example, these are all strings, right? So we know in JavaScript when we're working with strings, it's just words or letters, right? It can contain anything that is a string is going to be in that type of data. This ID column right here, we probably would define as an integer, right? So we know in JavaScript we've got number as a data type. Number can be, 5, 5.5, -10, but SQL goes even further, and so we have a couple different types of data types that we need to be aware of. The first is an integer. It stands for int, and that's a whole number from -1 billion all the way up to +1 billion, but it's a whole number, right? So if I put 5.5 in an integer field, most likely what's going to happen, depending on the database, it's going to warn us and say, you try to put 5.5 in here, and then it's probably going to silently truncate it to 5. Okay? Tiny integer is a smaller number, right? So one of the things that we care about in database design and construction when we start building our tables is we're going to pick the data type that is big enough to contain the size of the information we're going to store in here, right? Because databases were built at a time when we really care about the size of our table, right? A good example is like even just 20 years ago, a 10 gigabyte hard drive was huge, right? But if you're building a product that is going to be used by millions of people and you have tons and tons of rows in here, right? We want to make sure that the amount of data we're storing is correctly linked to the size of the information so that we don't run out of hard drive space, right? And the problem is when we create a column in SQL, if we define ID as like int, for example, integer can go from negative whatever to a positive a billion, right? And we'll actually look up these numbers so that we're not just making up examples here. But the problem is MySQL doesn't know how big you need to store, so it's going to allocate enough space to have the biggest possible number in here, right? Like that. So every record in your table is going to have that much space allocated for it, even if most of your records just say 3, 4, 5. So you can think of like the column, the data type that we're putting in the column is determining how much physical space the database is setting aside to make sure that it can store this information. If I'm building something that is, a good example is, this first name field, right? Like we can make some assumptions when we're designing our tables to say like, this first name field can only ever be, 50 characters long, right? If there's somebody that comes in with it has a 51 character name, like hopefully they'll submit a bug report and we'll change it. But we don't need to worry about someone with a some crazy long name because we're building a product that we're only going to consume. It's friends and family, right? I don't have any friends that have 50 character names, so the database doesn't have to put as much space in that, and so we can correctly design our database to cover those eventualities. But maybe last name we want to say this maybe needs to be 75, right? Because we know some people with some long last names and some people that have hyphenated names, and then email address. We might come in here and say this one needs to be 255 characters long. So the database will allocate the correct amount of size based on what type of data we've said this record will hold. Okay. And so integer is obviously that's your default generic number. Tiny integer is a smaller version of that. I think it's 0 to 2, negative 255 to 255. Let's look up these data types. MySQL data type sizes. Yeah. So tiny int, for example, is 0 to 255, right? Because it's just one single byte. Okay. You would want to use tiny int for something like if you were building a color picker, right? Because we know that RGB color codes are 0 to 255, and so you can make an R column, a B column, and a G column, and store 0 to 255 in a tiny int perfectly. Okay. Big int would be, you can see here, it's 8 bytes. So if you needed a giant number, you would want to use big int, right? If you were doing something with like cells in the human body where you got to count billions and billions and billions, right? Float is a data type that lets us track decimals, right? So 5.5 when you'd use a float. Varchar, this is a special one. This is what MySQL calls a string. So a varchar text and char, for example. Varchar is 0 to 255, so you're going to define a size. So you're going to use these for a lot of your fields that are like first name, last name, email address, where you know the size of this field is going to be relatively small. As soon as you get above that 255 number of characters, then you're going to want to use a text field. Text field lets you store, I think, 65,000. Let's check. Text. Yep. Text field size. Yeah. Text is 65,000 bytes, right? So that you can think of a byte here as like a letter, and it's dangerous to even think that way because like Unicode, if we're dealing with Chinese letters, right, it might be 4 bytes per letter. So you've got to pick a size that is correct, right? But it kind of gives you, like, a text is going to let you put in 64 kilobytes of text. Medium text is going to let you put in 16 megabytes of text, and then long text is letting you put in 4 gigabytes of text. So if you're Estrella's example where she's working on this like story engine, right, like 65,000 letters is a decent sized short story, but she probably needs to pick medium text or long text so that, like, if someone comes into her site and wants to write a novella, right, we've got to have enough size to store enough text that goes there. Okay, and then char, if you want to store a single letter or a few letters, that would be what you use that for. And then MySQL also has its own date field, right? So a date in MySQL, we can do special operations on the dates, and so in JavaScript we use the new date object. We're going to want to use the data type when we're storing that information in our database, so that we can say, hey, just show me the records from the last month, right? MySQL will be able to fetch and retrieve those records extremely quickly and very efficiently for us if we use the date field. Okay. So these will all become very clear to us as we start creating our tables, but just be aware that they're going to be similar to what you've been experiencing with JavaScript previously, right? Like int, float, big int, tiny int. I mean, that's a JavaScript number. So if you're ever using a number in JavaScript and you want to save it, you're going to want to use one of these column types in MySQL for your table. Okay. Varchar, text, char. These are going to be the ones that are your JavaScript strings, and then date is going to also be a JavaScript date, but you're going to convert it so that it's storable in MySQL. Any questions about these data types? No? What is another data type in JavaScript that we've learned about? what do you see is missing from here that we have in JavaScript? Andrew.
Arrays.
Oh, okay. Array. That's a great. So yeah, an array or an object in JavaScript doesn't exist in MySQL because the entire concept of an array is the database itself, right? So the table and the rows inside of it, you can think of this as the array that we would have in JavaScript. So a traditional operation, and we're going to see this over and over and over again this week and going forward, is that you'll have an array of records, and then you're going to loop through that array of records and insert each record as a line, as a row in the database. Okay? So, yes, it's missing, but it's missing because the entire concept of an array is the concept of a database table. What's another one? That was a good one. What's another data type? We learned about a bunch of different data types in JavaScript.
Undefined.
Undefined, yeah, that's a great one. So in MySQL, we don't use undefined, but we will use null. Null is the great value that means like there is nothing here and there's nothing here on purpose. Okay. Oftentimes, we're putting in a null. We're saying there is intentionally nothing here. Whereas, sometimes we might put in JavaScript, we might have an empty, or in MySQL, we might have a table that is a varchar and it might have an empty string, right? So it'll just be like, I'll use double quotes, right? So like an empty string where there's nothing in it. This does not mean null. It means this is an empty string. We stored an empty string. Or we might come in here and say, this is null. Okay? And so we're going to use null in MySQL to intentionally let us know that we have a record here, and this column, right? Like if I did not have a last name, maybe this is null. So that I know I can display the first name, like anonymous, right? Maybe I signed up for an account and I said anonymous is my name and I didn't put anything a last name. We'll be able to check and we'll say like, give me every record where the last name is not null. Or often you'll see this with email addresses, right? Like we'll do a query and says, I want to send an email to everyone in my database. Give me everybody that's not null. And we're going to see that quite as well. So it doesn't have an undefined. An undefined just means there's no record there, right? So it will be like zero records found. But we will use null for those types of things. What else? What's another one?
Boolean values.
Yeah, Boolean. Great. So Boolean, MySQL actually has a Boolean type, but what a Boolean type is behind the scenes is a tiny int that is 1 bit. So it's either a 1 or a 0. And so we're gonna, we can create a table and say, hey, this column type is Boolean, like has logged in, right? We might make a column that says, has logged in, and we might define this as Boolean, but behind the scenes it's really stored as a tiny int 1, right? And all it has in there is, a 0 or a 1, right? Because that's what Boolean means, yes or no, on or off. And so we might describe our table and say that this is a Boolean field, but behind the scenes what it's actually storing is a very small number. Cool. We have some other data types. These are going to come up pretty often. Especially as we develop with JavaScript. This is a kind of a newer data type, JSON specifically. It's, 10 years ago when JSON was becoming a popular data type, none of the major databases supported JSON natively at the time. And so what we would do is we would create a text field, and we'd say like, this is my user object, and we would just shove JSON as a string into a text field because that's really what it is. Since then, a lot of major databases, Postgres for one, MySQL, they natively support JSON, so we can include JSON in here as a value, and then MySQL is smart enough to know what to do with that, so we can look at information in that JSON record and have it tell us information back. Another data type that we may play with is called binary, where we're actually storing, like, if for whatever reason you wanted to store a small image or a file in the database, you could use binary and actually write those bits into the database. I've never used this personally because it's not a good idea. There are usually better ways to store files than to put it in your database. But maybe if anyone's curious, maybe we can explore like what would you actually use it for. I don't know. And there's a few other date types, date time, and then timestamp. Behind the scenes, that they're going to be very similar to the date data type, but they're going to have slightly different things that we can do to make changes to them. Any questions about data types? No? All right. Now comes the fun part. We're going to start diving in and like actually install some stuff and play around so that we have a SQL server on our machines. We're going to install one of these three environments: XAMPP, WAMP, or MAMP, depending on your operating system. So MAMP is the Mac development environment. It comes with an Apache, MySQL, and PHP. That's what the AMPP stands for. It's Apache, MySQL, and PHP, which is a very common server environment that you're going to see time and time again. We've been developing with Express because we're writing JavaScript for the first time. But when you're working in your real world jobs, most of the times your web server is going to be Apache. You're going to have a MySQL database, and the database is probably going to have the server is probably going to also have PHP on it. And so these little programs were built to let us have a server environment on our computers. So we're going to install that right now. Next week or the week after, whenever we start learning about deployments, we're going to actually upload our code onto the internet where it does the most good and people can access our software. And it's going to very closely mirror these types of environments. And so, that's one of the reasons that we want to download and install these. So what we're going to do is everybody follow along. I'm going to install XAMPP, right? So if I just go to Google, yeah, perfect. So if we just go to Google and type in XAMPP, and then click on this top link, which should take you to ApacheFriends.org. And it's going to tell you that XAMPP is the most popular PHP development environment, right? I'm going to click here to download XAMPP for Windows. Okay, everyone who's on a Mac, so Estrella and Andrew, you're going to use MAMP. So if we search Google for MAMP, you're going to go to mamp.info, and you're going to, yours is going to look a little bit different, but it should say free download, and it should have a Mac logo. It knows that I'm on a Windows computer, so it's trying to give me the Windows version. And you're going to click that and get it downloaded. When everybody has downloaded XAMPP or MAMP, we're going to run this program. I'm going to click yes so that it lets me install software on my own computer. Whenever the box pops up, I'll drag it over here. Doesn't activated use your account control on your system. Some functions using. I don't know what that means. We're going to assume that everything's fine. So is everyone here? And then you Mac folks, are you installing MAMP? And if you get hung up, Andrew and Estrella specifically, if you get hung up during this process, you can share your screen. I just installed MAMP on my laptop the other day, so I'm pretty comfortable walking you through it. So if anything doesn't make sense, we'll just get all the Windows people installed, and then we'll have you share your screen. Everyone that's on Windows, you guys all caught up to this stage? Set up XAMPP? Yep. Alright, I'm going to click next. We're going to leave everything the same, good. The important thing when we're here, we really care about this so that it installs MySQL for us and PHP MyAdmin. Alright, so we're going to click next. Folder to install XAMPP2, that's fine. Yep. English is good. We do not want to install Bitnami, so we're going to uncheck that box. Click next. And now it's ready to install on our computer. So it should do its thing here. Andrew and Estrella, while this is installing, how are you guys doing with MAMP?
Mine's installing.
Okay, cool.
Yeah, it's It's almost there. Cool.
This installation is going very slowly on my computer. Is it going faster on any of you other Windows folks? Nice.
It's about the same for me.
Cool. It's much faster on Mac. What's everybody having for dinner tonight?
I had pizza.
Nice. What toppings?
There's pepperoni and green peppers and pepperoncini. It was Fernandez.
Is that local to Thompson?
Yeah, in Thompson.
Huh. Never had that. Pretty good?
Yeah, it's pretty good.
Nice. Cool. So my Windows Defender firewall has told me that it's blocking some Apache stuff. It's trying to protect me from myself because desktop computers are not usually supposed to be servers. We're going to say allow access because we are doing this on purpose. Cool. And then I'll leave it here and wait for everyone else's computer to catch up. Let me know when you're all good. My wife is bringing me, she's making taco salad. She's going to bring it over here at 7. So we're going to take a break at 7. I'm very excited for taco salad.
Yeah.
Is everybody installed? We're still chugging. Poor Selena's computer. Chugging along.
I got held up for a moment, so I was like a little bit behind. And my computer's slow.
Alright, well, what you're going to do when yours finishes, Selena, is you're just going to click finish, and it's going to launch the control panel. So I'm going to start looking at that and drag it over here, right? So it's kind of hard to see. Obviously, I don't think I can increase the size of the fonts here. But it's got all these different servers that were installed. And you Mac folks, it's going to look similar to this, but different. And I can walk you through yours if you screen share. But Apache is the web server. So if I click that, I'm starting it right now. It stopped unexpectedly. It's blocking import. It's annoying. I'm gonna have to go to. It's probably because I installed it without the permissions. Ugh, I hate Zamp. I might have to like run this as an administrator. Let's try again. Okay. Oh my goodness, it's broke the whole computer. No one cares. Okay. I'm going to try installing this as an administrator, so we'll see if we can get around these Windows errors. Stupid Windows computer. Making everything difficult. Let's see if this helps. Does anyone else have that same problem when they click start on their thing? Is it blocking you, or did it start up?
It's working for me.
Okay, good. So it's just my computer. Figures. Oh, that's probably install. I don't know how to install things here. Alright, well, I'm going to uninstall this. Let's take a quick break. It's 5:50, and I'll see if I can fiddle with this and get it working on my end. This is a new computer, so nothing is configured correctly. It's 5:50. Let's come back at like 6:05. Cool. Recording. Alright, cool. Alright, so I've got Apache and MySQL started. That's really all we need for this. For those of you on Mac, I believe your default port is like 8888. But what you can do is you can open a browser tab now. If we go to localhost, port 80 or the default, right? You should see some kind of welcome page. The Mac welcome page is going to look a little bit different than this because MAMP is a different program than XAMPP. But what's important is that both of them install. Yeah, go ahead, Andrew.
I don't think I'm quite where you are.
Okay. Why don't you share your screen and we'll take a look.
Yeah, let's see what's up.
Oh, you're in MAMP Pro. You want to run just MAMP. MAMP Pro is like got a bunch of premium features and stuff. Let's click the red
Okay.
X. Yep. And if you do command space and type in MAMP, there should be two options, and one of them, go to the one below it, MAMP. All right, cool. And so your control panel does not look as good as our. You can close, little advertisement there. Your control panel is not as full featured as ours. They want you to buy the Pro version. You don't need it. So what you're going to do is you're going to click the start button. Oh, the start button over on the right. Top right. Yeah.
Do I need keep it on Apache?
Yeah.
Okay.
Perfect.
Okay.
So it's slowly starting all of the servers, and it should open a web page for you. I think yours is going to be localhost port 8888, 888848. I believe that's the default. For us Windows users, the default is the real web port 80. So, we go port 80. That takes us here. But what's important is it installed a MySQL database behind the scenes, and it gave us a cool piece of software called PHP MyAdmin, which is a web-based interface for interacting with our database. So if you, for those Mac people, you probably have to type this in manually. You'll type like localhost :8888/PHP MyAdmin. Should take you to this an interface that looks very similar to this.
Can you share?
Oh yes. Thank you. So So this is PHPMyAdmin. Andrew in Australia, are you guys here? Cool. And for us Windows folks, it's the same. We have a link on our page up here at the top right, PHPMyAdmin. And so this is an interface for our database. Now, if any of you have seen, I've been helping Selena with her homework occasionally. She's using a tool called MySQL Workbench, which is a free tool that MySQL, the company, puts out. And so, I don't know if they have they have an OS X version. So now would be a good time. Let's download that as well. I think I already have it installed, so I'm not going to, but I'll just download it and see what happens. No thanks. Just start my download. And this tool is going to be very similar to PHPMyAdmin in that we're going to work. It lets us interact with our database the same sorts of way. But the difference is MySQL Workbench by default, when you install it, it kind of gives you a lightweight version of the database inside the program, so you can play with tables and stuff. But it is not the actual server, and so we're going to have to. If we want to use MySQL Workbench, we're going to have to connect to that server that's running, and we'll take a look at that. And it installs. But for now, we'll just play in here for a little bit, and maybe we'll explore MySQL Workbench later this evening. Go ahead, Andrew.
I'm lagging behind. What was you said? Go to localhost. Mine's 8888.
Yep.
And then
/PHPMyAdmin. And what I would encourage everyone to do, especially while you're developing and things like that, is bookmark this page, because you're going to be here a lot. Go ahead, Gregory.
I have an error with my my admin thing. It says access denied, I guess.
Share your screen. Let's take a look. This is a really important step, and we'll spend literally all day making sure you guys all have databases on your computer. Because if we don't have it. Okay, cool. So you probably, if you pull up your control panel for XAMPP, XAMPP, this error here is telling you that it couldn't connect to the database, and so you probably didn't start the database, if I had to guess.
Okay.
Yeah, there you go. Easy peasy.
okay. I got it. What did you want us to do once we were on that page?
If everybody's on this page, that's kind of the step we're at right now. So
Okay.
we're going to start
Gotcha.
exploring. Okay, so this is an interface for our database. Over here on the left, these are the databases that exist inside this database server. So information schema, this is one that is default to MySQL, and it describes all of the information about the database. This is going to exist on all of your databases that are MySQL based. Same with MySQL performance schema. This is probably storing some information to help MySQL optimize. These, we just did this installation. So all these tables in here are tables that are specific to the database, to this specific server. You also see there's a database called PHPMyAdmin. This is a database that this program, PHPMyAdmin, is using to store information about itself. And so we can come in here and see these are all the tables in here. It lets us have special users. This is information that the app needs to do its thing. And then there's a blank database called test, which has nothing in it. Okay, so everyone follow along here. We're going to create our own brand new, this is our first database. So we're going to click the new button, and we're going to give it a name of, first DB. Okay. Everyone following along? Cool. All right, now I'm gonna click create. Now the database exists, and you can see that it is over here on the left. Right now, this database is empty. It has nothing in it, but we're going to create a table right now. So we're going to make a table, and we're going to follow kind of this, right? Let's do this, right? So we have a database here, users and posts. So let's start with that. So I'm going to make my first table as users. For the number of columns, yeah, let's do 4. And so we'll click Go, and that's going to bring us to the table creation wizard, right? So the columns in here are like all the columns in this table are the information that we need to include about our table. So this is one way to create a table using PHP-MyAdmin. If you're using MySQL Workbench, there's other ways to do it. And then we're also going to learn the syntax of how to create a table in SQL. That's the way I almost always do my work. It's just you get used to it and it's fast and easy. But we'll do it with the interface here, just as the very first version. So the name, the first column, each one of these is a column because we said it was 4 columns. Remember when we click the Go button? So the first column is ID, and we're going to leave this as an integer. And we don't have to put anything in length. The default, we're going to leave that as blank as well. And then we're going to say the index down here in the right is primary. And it pops up some kind of box. That's interesting. Okay. Perfect. And then right here where it says AI, that means auto increment. So that means this is a field that is going to be numbers, and MySQL on our behalf is going to, every time we insert a record, it's going to increase the value. So we want to put this on our primary key, which is our ID column. So we're going to put a checkbox there. Everyone following along? Okay. The next column, if we refer back to our little fake spreadsheet one, right? We had a first name, a last name, and an email address. Okay. So let's we'll do first name, last name, and then email. So I'm just going down the line here and making sure my columns all have names. Then I'm going to pick the data type for each of these columns. Okay. So first name, we said, hey, this probably needs to be 50 characters long. So we're going to do variable length character, varchar. And I'm going to say, hey, this is 50. This can hold 50 letters in it. I'm not going to select anything else in here. I don't need to put an auto increment or anything because this is not a column that, this is just a column we're going to put strings in. Last name is the same thing. I need to be a varchar, and let's make it 75 like we said. And then email, let's do varchar 255, right? So email addresses can be really long, unicorn fan club 1736 at unicornlover.com or whatever, right? That's a big string. We want to make sure we have enough space in our string to store that in MySQL. So ID, that's our primary key. That's how we're going to reference all of this, all the records in here. We're going to put primary, and we're going to make sure it says auto increment. And then our first name, last name, and email are going to all be varchars, and they're all going to, 50, 75, 255. And we could have picked any number we want, right? We can make these all 255. The reason we would not make these all 255 is because we know we're building a website that's going to take over Facebook. We want to have it take as much or as little space as it needs to, so that's why we're going to pick good sizes here. That's the only reason. Is everyone at this stage? Okay. And then you click Save. Right? So it created a table, and you can see it in here. Right? First DB has a table called users. Right? And if we click on this, it's going to run select star from user to show all the data that's in there. It doesn't have any data yet. We haven't inserted any records. Okay? The other table we had was posts, right? Let's make that one real quick. And it had post ID, user ID, title, comment, right? So that's another good one. We'll do it as 4, right? So we'll click new right here. It's going to take us back to that page. And we're going to give it a table name, posts. And we'll say post ID, user ID, title, and comment. Okay, so those are our column names. For post ID, what should we do to make it, like, this is the primary key of this table. Leah, what do I need to mark in here to make that work?
Um, uh, int and AI
Okay.
and
And so
uh,
I clicked AI, and this program, PHP was smart enough to know, hey, this is the primary key.
okay, I was
So
about
it
to say
auto
that.
selected it for us. That's cool. I didn't know it did that. User ID, right? We want to make this be a relationship to the users table. So this also needs to be an int. And the reason is because we're going to store information in here, the ID field that comes from the users table. We're going to store that in here. So these need to match. So we're going to put int. We don't want to put any other things in here, right? There's a we can index on the user. So if we know we're going to search by the user, we might want to put an index in here, but we'll talk about that later. We don't have to put anything else for now. Title, we probably want to make this a varchar. We think, a title is probably a couple words, right? So we probably can go 255 in here, the biggest size. And then comment, right? We want this to be text. And so we'll just come and pick text. If we knew for a fact that we were going to store really big texts in here, like we wanted to write a novel or something, we would pick one of these other big types, text, long text or something like that. But text is a good starting point. Okay, and then we'll click save on this as well. So now we have 2 tables in our database. Okay, users and posts. All right. Now comes the fun part. When you're using SQL, if we click on users, for example, it's behind the scenes. SQL is a separate language. Think of it kind of like JavaScript, where the language itself has some verbs and some nouns and some objects, and it's structured in a way so that we can communicate with any database server that understands SQL, which includes all the ones that MySQL, Oracle, Postgres. They all speak the same language, and this language lets us do things with the database. So select is the way we fetch information from a table. So whenever we want to read something, we're always going to select it. Okay. I don't like that. It goes to that next. So let's first insert a few records, and let's play with select a little bit. So before we learn about inserting, which is its own other query, we're gonna use the phpMyAdmin one in here, and we're gonna insert some users, right? So we're gonna say we don't have to put anything for the ID column because it's gonna automatically put information here for us, right? Because we picked it as auto increment. So we're gonna leave that blank, and we're gonna say first name Eric, last name Harrison, and my email address erh@theclubhouse. Okay. You guys can put in whatever records you want. We're just going to create a few records, and then right below it there's a little button that says go. So we're going to click go here, and you're going to show you the actual query that this phpMyAdmin ran. So it's going to say insert into users, values, null, Eric, Harrison, whatever. Okay. So we're going to learn this syntax later today, but for now we're just going to insert a few records. So what I want everyone to do is get at least 3 users in your users table. Okay, so I'm going to do that while you guys are following along. I'm just going to click insert. I'm going to say Meg. And I'll insert another one. Does everyone have at least 3 records in your users table? Yes? Still typing?
Yes.
Cool. Alright, so when I click on the users table now, it's running select star from users, and it's showing the 4 records that I inserted into mine. Okay, so let's play with SQL a little bit. This is kind of the default so star means give me everything. Is that hard to read? Is that better? So select is the word that we know gives us information back. Star is the columns, right? So it's saying give me every column. From is telling us where to look for it, and then the users is the name of the table, and then we can take out where one. We don't need that. So select star from users. This is like the most simple query that you could ever run, and it's going to return every single row that is in the table. So if I run this now, and I click go down at the bottom, it's going to say it ran select star from users, and you can see the 4 rows that came back. Everyone following along? Okay, other ways, let's edit in line here, right? So these select star from users gave us this. I can, instead of star, I can specify what columns I want to have back, right? So this table has ID, first name, last name, and email. If I just wanted to get, first name, comma, email from users, that's going to return just those 2 columns. So whatever I put, after the word select is the names of my columns that I want to retrieve. Almost always, so when I first started programming way back in the day, I almost always would do select star from everything. And if I had a table that had 200 rows, I'm going to get every record back and every column. I didn't care. What I have since started doing and gotten into the habit of over the past 10 years really is being more explicit. So I'm almost never going to run select star unless I really just want to get a sense of what data is in the table. Because when we're doing select, right, so MySQL behind the scenes is running your query, grabbing all the information, and then sending it back over the internet or sending it back over the network. And so then your programming language, when we start working on this in JavaScript, has to get all those records, put it into an array, and so we're just causing the size of our programs to balloon, and we're having to use more and more resources, specifically memory and network communication. If all I was doing was just getting a list of emails, like I would just say, give me email from users, so that I don't have to fetch all those records and send them over the internet and then have my program loop through all those records. Okay, so it's the verb select, then the columns that you want to get back, or star, from, and then you're going to put the table name. Now, the thing that makes JavaScript, the thing that makes SQL super duper powerful, let's just say ID, first name, last name, right? The thing that makes this super duper powerful is that we can also include clauses to tell it what information to send back, right? So I can say where at the end, right? So select column names from table where, and I can put in some Boolean logic. Think of this as this is the same sort of stuff that we've been doing in JavaScript, where we're saying if ID equals 2, or if first name equals Eric, or if ID is greater than 3. So we can do any and all of those Boolean logic in here, right? So I can say where ID equals 1, and that's just going to give me my first record. Or I can say where ID is greater than 1, which is going to give me 2, 3, and 4. I can also combine these, so we can make complex nested queries in here. I can say where ID is greater than 1 and ID is less than 4, right? So it's going to give me just 2 and 3. I can also look at different columns for my information. So here's another one. So let's take out where ID is greater than 1 and first name equals Isla. Okay. So it's going to return anyone that had Isla that was greater than 1. Okay. And this is extremely useful when you're dealing with users, right? Oftentimes, I'm sure you guys have seen this on your programs and some websites you've been to, you have a user ID and it's going to be like, I'm user ID 35. And your queries for that kind of thing are going to be extremely simple, where you're just going to say, hey, give me the user information where user ID equals 1. And that'll be my user record. Okay. What else? Another cool thing that you can do, right? So the where clause goes after your table, where ID equals whatever, and it can be whatever you want. Let's take out the where clause real quick. Right? So that's all 4 of our rows, but we can also change the ordering, right? So we can say order by ID desk, right, descending. So it'll go from biggest to littlest, and you can see now my rows that have come back have been in an opposite order. Now, we've learned how to do this in JavaScript, right? Where we can start our for loops at the top. Like if the array had 10 items in it, we could start at 10 and count down. This is the same thing, but we're letting MySQL do it, and it's doing that query in less than 1/1000th of a second. So MySQL has been optimized as a database to be very, very, very fast. You could have 1 million records in here and write a query that will work faster than your JavaScript. So this is one of the reasons why you want to get really good at knowing at least the ins and outs of how to write efficient queries, because we're going to be able to store tons and tons of information in these databases and have MySQL give that back to us. And if we write our queries correctly, rather than returning 1,000 rows, if we know we only need 10 rows, we can have MySQL give us the 10 rows, and then our JavaScript only has to loop through 10 records instead of 1,000 records. Okay? So that's kind of the structure of select, right? Select first, then the columns that you want to select from, then the word from, which lets us know, hey, the thing that comes next is going to be the name of the table. Oh, excuse me. The name of the table. Then is going to be the where clause, where I equals 1, right? Anything that we put in here inside the where can be Boolean logic, right? So we can use where ID equals 1, and we can also use or ID equals 2, right? So if I change this to and right now, and I run this, go, it's gonna return 0 rows because I don't have any records in here that have an ID of 1 and an ID of 2. That's impossible. But we can write any and all, like all the Boolean stuff we've been learning in JavaScript, you can do inside the where clause of MySQL. And it's maybe important to think of this like in terms of blocks of stuff, right? Like, so when we do where clause in here, just imagine there's like parentheses wrapped around it, and this should actually run as well, right? Like, this is valid. We can have nested queries, but think of each section as like select is what we're doing. The next thing that comes up is the columns that we want to get back. Then the next part is from the table. Then the next part is the where clause, and then the order by. So that's kind of the final thing. There's other things, and we'll look at those as they come up, but this is like the basics of fetching information from a database. Okay? And there's a ton of power in the where, and there's a mountain of power in the order by. Right? There's more power in the where than the order by, but they're very useful, right? Like, if you had a giant list of information and you wanted to just swap it around so it was reverse sorted, like the easiest thing to do is just tell MySQL order by whatever descending, and now it's reversed. You don't have to worry about looping through anything or changing your code or anything. You can just tell the database to give me my records back in a different order. You can also, right, let's take this out. Just say here 1. Right. So right now we're ordering by ID. We can also order by other columns. So let's order by first name, for example. Go. And now, yeah. I'm descending. It's like, why is this in reverse alphabetical order? So when you're ordering by, ascending is the default, right? So it goes from smallest to biggest. Descending is the opposite, which is biggest from smallest. So you can either put ascending in here to be explicit and say, definitely order by this ascending, or you can leave it out. Either way is fine. So now you can see this is going in alphabetical order. So D-E-I-N. Okay. So you can order by that. You can also order by, let's assume we had another person here. Make a new, maybe there's another Isla Fisher, right? The actress. Some actress at gmail.com. Right? Cool. So let's go back to where we were. Edit inline. Cool. So now we see we have two ILAs in here. One's ID 5 and one's ID 4 or ID 3. But what were we doing? We were selecting ID, first name, last name, email from users, where, one, and order by first name. Go. So now we have Isla Harrison and Isla Fisher. You can see that it picked like F is before H, right? So you would think that Isla Fisher should be above Isla Harrison. We probably, but the problem is it by default, like this ID column is our primary key. So the database thinks this column is super important, and so it's going to try and preserve this is like the default behind the scenes ordering mechanism. But we can come in here and say order by first name ASC, last name ASC, right? And so now, yeah, Isla Fisher goes on top of Isla Harrison. So you can order by multiple columns, and if one criteria matches or is the same, then it goes to the second part next. Does everyone kind of follow along with that? Okay, so that selects. When we've been inserting, right, this is the other major operation you do, right? So let's put in Dexter Morgan, right? And he's forensics at miami.gov, right? Whenever you're doing something in PHP-MyAdmin is a really nice tool because it gives you an interface to like not have to remember things. This is like a great tool to give to if you're working, with business analysts or somebody who needs to be able to update information in a database, but they don't necessarily know SQL. But the tool is excellent because it's telling you exactly the SQL it's doing. So let's take a look at this. This is an insert. So we've learned, what did we call the acronym of what we're doing here? It had a funny, dirty sounding name.
CRUD.
CRUD. Create, read, update, delete. So the read operation is select. The create operation is insert. So your insert, and it has a similar type of syntax, but the things that we learned about select are slightly in a different format here. So insert, and then into, and then the name of the table. So you're going to insert into users, then you're going to put parentheses with the columns that you're inserting into, ID, first name, last name, email, and the values, null, Dexter, Morgan, forensics at miami.gov, right? And we could edit this in line, right? If I click go again, even though we already have a Dexter Morgan, right? It's going to make another, here, let's pull this in another tab so we can see, right? So Dexter Morgan's in here twice now. Every time I run insert, it's going to continue to update this information. Now, we obviously don't want that, right, in this specific case. But what we probably do is write some kind of code that prevent us from having these, the same email address be used twice, for example. But we can, when we're writing our code, we're not going to be, we're going to build a form that says like, in Andrew's example, like, hey, new golf game. I'm on hole 1. When I put in your information, you click the submit button. Behind the scenes, it's going to do insert into golf scores, ID, course ID, hole, shot distance, values, 1, 1, 4, 35, whatever your values are. So you're going to write code that runs this line of SQL to actually do the insert operation, to actually store the information in the database. And the format is always going to look exactly like this. Insert into, then the table name. These right here, right, this is us being explicit. If I did not put this information in, I could do insert into users values. And as long as my values here match up exactly in the order that they are defined in the table, which was ID, first name, last name, email, this would be perfect. But if I was to come in here and say, right? If we tried to just like shorthand this and we didn't have the data that we're having in the values fields match up with the table, this should throw an error. Yeah, it's going to say column count doesn't match row value count at row 1. So it's going to give us an error saying like this is wrong. But what we could have done is we could have said, how do I do I get this out of here? Wait, what? Oh, I just have to click it. Right, but we know ID is going to be null, right? So I can take that out. And so we can shorthand things and say, you know, first name, last name, email. Whatever columns I put after the table name is the ones I'm going to insert into the database. So I can go like this, and it inserted. ID was null in the first place, but if we come over here and we refresh our, I refresh this. Let's just click it again. You can see that it knew, hey, because this is an auto increment field anyway, I'm going to put the number 8 here. Okay. We could also, right, ignore some of these values, right? I can say, you know, I don't, maybe I don't know their last name. So as long as the records over here, the column names match the value names, we can get away, right? So it gives us a warning here, field last name doesn't have a value. That's letting us know that when it inserted, right, this is now blank, this is empty. Okay? So that's the insert syntax, right? But we know now that ID 9 is missing its last name, right? The way we would update this, right? We have another SQL syntax we can use here, and that is update users set last name equals Morgan, where ID equals 9. It's really that simple. We're saying update this is the update verb in the CRUD acronym, and it's update here as well. Update, we say what table we're updating, update users, and then we're saying set last name equals Morgan, where the ID is 9. So it's going to come in here and it's going to say find this record and then update the value. Right? So I can say, bloop, if I click go, it worked, and if I click here again, we can see now that Dexter Morgan was in here, right? Everyone kind of follow along. So we've learned select gives us information, insert creates a brand new record, update gives us lets us update fields, right? We can, right. So we did set last name equals Morgan, where ID equals 9. We can set multiple things in here. So we can say what was his sister's name in the movie? Deborah, right? So first name equals Deborah, and then we put comma last name equals Morgan. Yeah. And I click go. Okay. And so now if we look at that, right, we've updated 2 fields. So Deborah and Morgan. Okay. That brings us to the last part, right, which is delete, right? That's the last thing. And the syntax for that is kind of cool. So we've got 6, 7, and 8. These are duplicates. So let's delete records 7 and 8. And so the way we can do that is delete from users where ID equals 7 or ID equals 8, right? So the where clause, right, as long as this is Boolean logic, right, it's going to find those records that match that criteria and delete them. Okay, so 2 rows were affected, and if we come over here and check our table now, we should only have 1 Dexter Morgan, and you can see we skipped, 7 and 8 because we just deleted those records, and goes right to 9. Pretty simple. If we run this again, let's run it again, right? Yeah, good. The code is correct, but it's telling us 0 rows are affected because we no longer have any rows that say 7 or 8. Right? Now, let's go back to insert again. Null. Harry Morgan. Right, that was his dad. Detective at Miami.gov. Right? Cool. And so if we go look at users now, you can see that the auto increment has continued with from 9 to 10. So it's always going to take the highest value that is in this auto increment field and go to the next one, even though there's gaps in here, right? Like, why wouldn't it update and go to 7? That's because it's always going to look at the highest number, and it always keeps track of this, right? So if I delete Harry, right? So now there's a 9. If I insert a new record here, let's add him back. Harry Morgan, detective. Whatever. I spelled that wrong. That's fine. Cool. So the row was inserted. Now you can see he's 11. Because MySQL behind the scenes with auto increment is keeping a track of like what was the last inserted ID, and we're always going to do one higher than that. Even if there's a high, 9, you would think it would go to 10 again, but we deleted 10 already, and MySQL knows this for us. Any questions? With those 4 operations, select, update, insert, and delete, you can build literally any program that exists. These are the basic building blocks, and it does not get more complicated than this. Now, when you start building actual crazy apps and you're doing cool stuff, you're going to have more complicated queries, for sure. You're going to have a whole bunch of where clauses that check to only show you the records that have, a birthday in the month of May, and we'll explore that later this week for sure. But this is as complicated as it will ever get. Select, update, insert, and delete. If you just sear those into your brain, you can build 99.9% of anything. It's funny because Selena has some homework of stuff I've never even seen before, because you'll never use them as a developer. Just never. If you're a database administrator, yeah, sure, you might do some fancy stuff in the database, but with select, update, insert, and delete, you can code Gmail, you can code a golf app, you can code a blogging story writing tool, you can build a poker game. Those 4 things are the atomic functions you need to make databases work. Now, let's take a look at the last most complicated thing you'll probably ever use, which is, we know that these 2 tables have a relationship, right? If we look at posts, for example, this is empty, but we see that it's got an ID field of its own. We have a user ID, we have a title and a comment. So let's add some stuff in here, and we'll do this right here. Let's say post ID is null, user ID is 1. We want Eric to be hello world, right? And my comment is, this is a long comment. Look at me go. Yay, right? I'm going to copy that. Okay, so I'm going to insert that. Let's edit inline. I'll just go again so it inserts a couple times, right? So if we look at posts now, we see we've got post ID, post ID, post ID, user ID, right? So that's kind of the same thing we were playing with in the table. All right. So what if I wanted to see all of the posts, right? We know that if we click posts, right, I can say select star from post, but I don't know what user this is. This is one of the, this is why you use a relational database, and it's called joining, right? So we can join information from this table from the other table, okay? And I'll show you how to do that right now. We're going to dive into joining in this might be all we talk about tomorrow. But let's just take a look here. So by default, it's doing select star because it's just trying to show us everything that's there. But let's be intentional about this. So we'll say post ID, user ID, title, comment from posts. So same query, gives us the information back. Okay. But I want to get information from the users table as well. So I can use what's called a join. So from posts, join, and then I can put in the table name, users on user ID equals users.id. Right? So whenever, this is something you need to be aware of, and this is something that you should get in the habit of as well, is that we remember we were talking about the database structure. The biggest thing is the server, which contains databases, which contain tables, which contain columns. So we've been writing columns just like this. So we'll say user ID, title, comment, okay? But you can also reference these kind of in JavaScript object format as well, right? So it would be like posts.comment, posts.title, posts.userid, and posts.postid, right? So if we explicitly tell it what table to look at, that's fine, right? So we have just said we're going to join users on user ID equals users.id. And so if I come in here and say posts.usersID.users ID, right? So we got 2 separate tables in here. So we want to make sure that we know we're talking about the right fields, right? And this one is an easy example, but most of the time, like when I'm building tables, I'm going to have the ID field always be called just ID. So I intentionally went out of my way and I said, hey, this is post ID. All right, let's change that structure. So let's edit this. Change this to the word ID just to show this off. So when I'm building tables like this, I'm always going to have a primary key for the table, and it's going to have the word ID because I like simple names and I don't like having to guess what my what my columns are called. So if I'm in here, let's right, what do we do? Select. Get out of here. Control S. Select ID, user ID, title, comment from posts. Right. This is kind of where we were when we stopped. Right. These are all the information. But now if I come in here and I say join users, right, and I click go, I'm going to get an error because it's going to say column ID and field list is ambiguous, and that means it doesn't know what ID I'm talking about. Right? Get out of here. So if I, so what it's a good habit to get into is always include your full table name in your SQL, right? So that there's never any problem in the future, right? So if I run go now, the query worked because it knows, hey, this is information. Now you'll also notice, right? I joined in users, but I did not. You'll notice that like we have 3 posts, the 3 records in this post table. But you'll notice that's returning back a whole bunch of stuff. 1, 2, 3, 1, 2, 3, 1, 2, 3. Because we joined to users, and there's a lot of information in users, right? So if I come in here and I say users dot first name, right, just as a quick example, you can see it's saying Eric, Meg, Isla, Dexter. So it's combining both tables and giving me everything back, everything that I've asked for in my columns. But what we generally would do with joins is we'll say join users on post.id, or post.user ID equals user.id, right? So we're saying when we join these, we want to join them on that column they have in common. So we have a user's ID column that has 1 in this case. So now when I run it, we just get the 3 records, and we can see that the first name is Eric. We pulled that from the users table, and that's smushed into our information here. This is our like return from our database. There's a bunch of other kind of joins, right? So this is a full join, right? So there's also a left join and a right join, and I'll show this off, right? So left join, right? So this should do the exact same thing, right? Yep. So it's joining this table, right? It's joining this table to the left of it, right? If we do it the other way, right? Right join, right? Now you can see that it joined the post table to the right, so it's choosing the direction that it joins content together. And now you can see all of the information from the users table is there, but any place that doesn't have a comment in the post table, it just gets a null. So you have to understand there's directionality here. Almost always, like when I'm writing code, when I'm writing database queries, I'm almost always going to design my code to just operate from a right to left direction, right? So I'm going to put whatever I'm querying first. Like in this example, I'm trying to get all the comments in the post table. And then I know I want the information from the users table. I'm always going to have that be the second table I joined from. So I'm going to say, give me everything for posts, and then smush in the user first name and last name and email address so that I can display it on my page, right? And so we'd probably come in here and say users dot last name, users dot email, right? So I can then see all the information that I needed, I got for free by using a join. But both of those tables get to remain just as small as they need to be. Remember we were talking about on this page, we could have included this information in here, but it's far better to just have the table just have the information it needs to have, and then we slurp it in with letting MySQL do what it's really good at, which is combining and showing us the relationships between things. Any questions about this? No? You guys are all geniuses now? Alright. What's up next? Alright. So we've been playing with, when we did the new table here, this is another piece of syntax that I use pretty often. So we've been writing these tables like this, using this interface. The other thing that I will often do when I'm in Visual Studio Code specifically, I almost never use a builder like this. What I will always use is I will come in here and I'll make a file and I'll just call it dbschema.sql, right? And I'm gonna create my tables manually with my code, right? So behind the scenes, when this program is running, right, it's running this actual syntax. What it's actually doing is create table, and then it's the name of the table. So users, and it's saying ID int not null auto increment. Okay. First name barcar 50. Last name barcar 75. And then email barcar 255. And then it'll say primary key ID. Like that. I think that should be correctish. So I'll create my table like this. This is the actual code that's running behind the scenes. And we can come in here and say show create table users. Right, so MySQL is smart enough to show us like, come on, give me the copy. It's like too small or something. No, come on. Oh, I see that. Wait, what? I clicked that button. How do I expand this? Full text. There we go. There we go. Cool. Yeah. So this, when we ran into PHP-MyAdmin, it's running this exact syntax. So this is another SQL operation. So we can create tables in SQL, right? So when we did it in the browser in this PHP-MyAdmin, it's just behind the scenes running create table users ID, and then it's saying int 11 because that's the full size of the ID, not null auto increment, first name. Okay, so it's everything, and then this stuff at the end is telling it what database storage engine to use. So that, like, this is high level profiling stuff. Like if you're a database engineer and you're optimizing for like query speed, you might change your database engine. You might so like auto increment here is telling us to start auto incrementing at 12 because we already have 11 other records in here. Default, and then the character set UTF-8 MB4. This is telling us that we can store Unicode letters in here, but all this stuff is unnecessary for the most part. So this syntax, what I'll do is I'll create a schema file and I'll include it in my app, and then all of the tables that I know I want to build, that my app is going to need, I'm going to have available to myself in a file like this. And then when I'm ready to create my tables, all I do is I just copy this and I'll copy it and run it in here. Right? So this is going to fail because we already have a users table. Right? Let's run theirs. This will fail because we already have this table, right? Table users already exists, but that's what it's doing behind the scenes. So very rarely will I have PHP-MyAdmin on my computer because I'm going to have to, we're going to deploy this code to a server somewhere, and then we're probably not going to have PHP-MyAdmin on there. So getting comfortable with this create table syntax is going to be very important to you for your life. And it's fairly simple, right? So we can come in here and say create table hosts. Even escape it correctly if we wanted to, and ID int 11 not null auto increment. What do we have? User ID int 11 not null. Title car 55 and text. Primary key ID. Okay, so that's the syntax for it, and so I'll just have that in a file ready to go so that I can, work on it here on my computer. And when I'm ready to put it on a server, these tables are ready to be created on the actual database. That's the high level view of like how you're going to build tables and schemas. And when I called this DB schema. schema is a term that describes like this is the structure of my database tables. Like these are the tables that exist. And so there are a lot of cool programs. Selena has a good one that she's played with in MySQL Workbench. We'll take a look at that maybe later today, where you can actually visualize the relationships between the tables. So that's a really good way to view a schema if you need help building a mental model of what the tables do and what the relationships are between those tables. Cool. All right. It is 7 o'clock. My taco salad just arrived. We're going to take a break, 15 minutes, 7:15. We'll come back and we'll do some more playing. All right, cool. So I think the next cool thing that we want to try, really just show off, is how we're going to use the things that we've learned today in the context of like building programs from Node, right? Let's make a new. I'll do it through Git Bash. Why is everything always small? Small is better. All right. All right. So I'm gonna go back to my main directory, CBC 12, and I'm gonna make a directory called DB. Fun. Okay. Fun. And I'm gonna run git init to start not git init, npm init to run it to turn this into a node project. DB fun is fine, cool. No description. All right. Yep, fine. Cool. So we're all tracking like we're just creating a node project here. I'm gonna open this with Visual Studio Code, so it's a little bit easier to work with. CBC 12, DB fun, select, cool. All right. So right now we have very little. We just have a package.json. We know we need a new file, and we're gonna call this index.js. Okay, cool. All right, let's pull up a terminal. All right. The first thing we need, because we're gonna work with MySQL here, is we're gonna say npm install MySQL. Should be it, right? Cool. Yeah. So now we have the MySQL module, which comes with a bunch of string parsers and all kinds of stuff, but it's available to us. And so what we can do is we can say const MySQL equals require MySQL. Okay. I might have to look this up because I don't remember the syntax. Let's see. Node. Let's just do npm MySQL. It's going to give us all we need. All right. Cool. Yep. I'll make this smaller here. Oop. We'll just type in what they're telling us. All right. So we've got ourselves a MySQL object. We're going to make a connection. Const connection. Right. That's what actually is. Our program is going to connect to the database and do something. Right. Well, we're going to run all of our queries through this connection. This is the object that we care about. So we're going to create this by saying MySQL.create connection, and this takes a couple different things, right? Host is one of the things, right? We're passing an object of parameters, and I can just as easily let's put this up here. Const MySQL params equals object, right? And we'll say host is localhost. User, I don't know what our username is. I'm gonna find our username for the local. That probably tells us on the XAMPP website, right? Because we need a username and password to connect to our database. I don't know what XAMPP is. Yeah, here, I got a better idea. Let's make a user. Yeah. Home. I make a user. Let's look at it small. Oh, we're connected as root. All right. Let's just say root. Password. Maybe it's blank. And then database is what do we call it? First DB. First DB. Right? So I can pass this object into our create connection option here. So I will say MySQL params Okay, and let's just see if we run this, if this will work. npm, or actually node index.js. Okay, it ran and did something. Cool. So let's make a query, right? So, I have to connect. So we'll do connection.connect. Right, that's what actually makes the connection happen. So maybe let's try running this and see if we actually connected, or if our password is wrong. Okay, cool. Looks like it worked. All right. So when we're here, we can run queries. So I can say select, ID, first name, last name, email from users. Okay, and this function takes a callback. Right. So we have to say function. Gosh, it's so hard to see this with everything so small. And the first argument is the error. The second argument is the results array. Okay. And so what we can do is, if error, we can do a console.error, right? Otherwise, we're gonna want to loop through the results. So we'll say for var I equals 0, I is less than results.length I plus plus. And we'll just do console.log results I and see what happens. Right, so we got, I think we have 8 or so records in this table right now. But we're running this query, select the ID, first name, last name, email from users. And then when that query is complete, this callback function is going to run. And it's going to pass us, if there's an error, it will be the first parameter. Otherwise, it's going to have an array of results. And so if we run this now, it should log out each record in the database. Yeah, perfect. So you can see here, the object type of that results array is, row data packet. That's, the class they define this with. Then it has ID, first name, last name, email. So we can, instead of results I, we could say, first name plus results I, last name, and let's put a space in there between them, right? And if we run our program again, now it should just say this is a list of names, right? So this is, to me, the most powerful thing that we need to know to be software developers is A, we know how to do these in SQL, select, insert, update, and delete. And B, we now know how to connect to a database and make a query to it. Okay, the same thing, right? So we know that this is how we fetch information from the database with the select. We can also in here connection.query. We'll do insert into users, values, null, what was it? First name, so we'll say Eric Harrison 2, email, right? Function, error, results. Okay. Now, the insert is not going to give us necessarily any results, but let's take a look at that. We'll console log it anyway. Console.log results. This should work. So it is giving us a results object and it's telling us, hey, the new record was inserted with ID of 12. So we get the insert ID out of here. If there was any warnings, or I don't know what protocol 41 means. If we were doing some updates, we would have information here telling us how many rows were changed, because the only one that returns records to us is select. All the other ones, update, insert, and delete, are just modifying existing records or creating things. So they don't return anything back, but they are going to return back information. So if I run this program again, it's going to insert another record, but now you'll see Eric Harrison 2 is there because we inserted that record. And now the next time I run this, there's going to be 2 Eric Harrison 2s. Right? So you see it's just running that insert over and over and over again right here. Everyone following along? All right. Now, how does this work in the context of web development? What are we going to do with this as we build things, right? So let's turn this into an Express app real quick, right? So let's take this stuff out. So we know that we can, let's see, npm install Express, We're gonna make this a little website real quick. And we'll do const express equals acquire express, and we'll do const app equals express, and then we'll do app.use express.static. We'll give it a folder, templates. Let's make a templates folder real quick. New folder. Templates. Ooh, actually, a better idea. Let's do app.listen 3000. We've got nothing on 3000, right? Localhost port 3000. Cool, nothing there. All right, so we've. I'll move this down. So let's just walk through this line by line, right? So we already had our MySQL connection. We created a connection to it. This is our server that's running with either XAMPP or MAMP. Okay. We just turned on Express, which we were playing with 2 weeks ago. We're turning this into a web server as well. We're saying the app is this. But now what we can do is we can say app.get, we'll just say /users, right? Function, res, right? So that's our request object and our response object. So whenever someone comes to localhost port 3000 and they go to /users, let's just display a list of users, right? So we can do connect. Oh, I gotta move all this out. All right. So let's put some comments in here so we don't lose our place here. Connect to database. Okay. Set up our routes. Okay. So before we send a response back, we first want to fetch the records, right? So in this user's example, let's just say connection.query, select ID, first name, last name, email from users, right? And that function we know takes an error and a results. And then inside this connection, when the callback happens, when the data is done, right, it's going to be in this results object. We want to then respond, have Express send it back to us, right? So we could do something like, here, let's just make this let output equals, right? It's empty string by default. And then I'm going to come in here and say for var I in 0, I is less than results.length I plus plus. And we'll say output plus equals results I dot first name plus results I dot last name. Okay, and maybe we'll put a let's put a line break in as well, NPR. Okay, and then once this loop is done, once we've looped through our records, we need to send it back out through Express. So let's do that. Let's do res.send, and we'll say output. Right, so this is just going to be a list of names with a line break at the end. So it's kind of like HTML, so the browser will interpret it as such. So let's run our, oop, I already pressed up. So we're going to run node index.js, our server is running, and if we go to localhost port 3000, right, it's going to give us cannot get because we didn't define a route for /, but I can come in here and say users, and we have a list of our users from our database, right? We have the building blocks of a dynamic website with pulling information from the database. And it's really this simple. Now, we can build better. Obviously, we spent the first 4 weeks of this course trying to build really cool interactive websites and make them very pretty. You remember when we were using the fake API? One thing that you might want to do with Express is have Express serve all of your beautiful HTML content, and then rather than outputting strings like this, right, we might just instead come in here and say, instead of even looping through this, right, we might just do res.json results. Let's see what this does. Let's close our server and restart it. And there you go. We've got JSON that's being sent back that our API, if we were building a website, like you wanted to build a table that had users and stuff, it could just slurp in this information. Any questions?
I will have lots of questions later when I can think of them.
I need questions now. 'Cause I gotta fill another hour.
Later, when we're not doing this and it's like 11 at night and you're ready to go to bed.
Perfect. Gregory, go ahead. You're muted. Oh.
Besides tables, can you have like files, like documents, like say you don't have a server for like a library, and you have like books or videos. Can you SQL to store those videos and able to search them?
You can. There is a data type called binary that lets you store binary data like videos or pictures and stuff. It's not recommended. There are way better ways to store files not in a database like this. So what I would do in this example, let's chug along with that example. I would maybe come in here and say, right, we've got a templates folder. Let's make another folder under here called like files, right? And inside files, let's make it file index.html. Here. Okay. Files. Let's say we've got like I don't know how many pictures or movies or something. I'm just gonna make this up. So it's gonna be like file.html, but pretend this is a movie. So file.mp4. Okay. This is a movie. Right? Okay. Just use your imagination. What I would do is in our first DB, I'm gonna create a table and we'll call it like files. It's gonna have an ID. It's gonna be auto increment, right? And it'll be like file name. That'll be a varchar. And make it like 100. And then it'll have file path. Varchar. 55. And I don't need 4 rows. No. Maybe we'll just put type. File type. Varchar. 40. Alright, I'm going to save this. Alright, so I made a files table. What I would probably have in here is, file name is file dot my cool movie. File path is files / file.html. Is that what I named it? Yeah. And then MP4. Right? So I'll have the database store information about where to find that record. Right. So if I was in here, let's make ourselves a new route. So like app.get files. File movie list, right? Movie list. Okay. Rec, res. Yeah, let's just copy this real quick. Action query, select, file name, file path, file type, files. Alright, so when we make a query to get this list of files, right, we're probably going to want to have it build, like a list. So I might even come in here and say like let output equals unearned list. Right? So we're going to start from there, and then I'm going to say for var I equals 0, I is less than results dot length I plus plus, and then we'll do output plus equals li ahref equals files. Let's actually use the template strings. It'll be easier to not have to fiddle with it. And we'll do results I dot file path, okay. And then results I dot file name, okay. /l/a /li. close it down here. There we go. Good. Yep. And then at the very end, we say output plus equals, and we got to close our unordered list. And then we res.send output. Okay. So now if I go to movie list, right. Got to restart my server. Movie list. You can see that the records in the database, it's like a link to that file. Can I get files? Oh, I put too many things. The path had the full link in there already, so let's fix that. Yep, my cool movie. Now this is linking to files, file.html, which is, if it was actually a movie or something, right? They would say, this is the movie, right? Or start playing. Because we have told Express that we're storing our files in this folder, and then we don't want to clutter up MySQL with a bunch of binary, like movies can be gigs, and even pictures, right? Like a high resolution photo is maybe like 30 megs, right? Like we don't want to store that in our database. That clutters everything up. But we can tell the database, hey, the location of this file is here in this folder. And so if we went in here and added, like another file to my other cool movie, let me just run this, right? This page is going to have that other link, right? This file doesn't exist here because we didn't create it. But what I would do if I was building this kind of program is I would, if we had a form that was creating like, add a new movie, right? You're going to put in the movie title. You're going to put in, a synopsis of what the movie's about. Maybe you're going to put in the director, all that kind of stuff. And then you're going to have a file picker, and you're going to pick the file that you're uploading to the server. You're going to upload the file and all that information. You're going to store the information about the file in the database, and you're going to just save the file directly to your hard drive or to an S3 bucket or someplace where, someplace that's for storing files. Does that make sense? Go ahead, Gregory.
Okay, I just thought of something. You did say that SQL won't be good for if you're trying to sell movies or pictures that something have a lot of storage. I have an idea that correlate to Aaron project with the golfing or the SSI chart. How could I say make a server? A server. So that let's say like a user login, how he make the login, how I could make my user when they come into the web page to log in and they could like tally or record their own data but it's always shows up there and they could read it instead of me constantly have to go to the back end and fix it. Why it could be easier to like say like have we got make PHP onto the webpage session. Make it like an easier way they could edit stuff. So they see what I see. It's just like a simple table. You can add in or delete table, and it will correspond to what's.
I don't think I quite understand your question. Can you like rephrase it in a smaller way?
I'm trying to. Okay. Instead of what they see as a in back end web developer, how we see PHP, how can we simplify it so when they go on our website, they mostly of the assets of what we get from HTTP, but simplify so like they can like have blocks of tables that can add in whatever they want to add and take out whatever they want to take out. As in when they doing they record of how many games they play in the golfing or what exercise or activity or calorie that they lose for the day or what they weight.
Are you asking how would you build a website to connect to the database?
Yeah, and they could see the database and they could edit on the
So that's
website.
That's really what we're learning right now is exactly that, which is we're learning how to connect to the database and make queries. And the next thing we're going to start playing with is you very rarely want to let them actually edit the databases or the tables because the tables are going to be stuff that maybe you don't want to show them. But what you'll do is you'll build interfaces that let them save information in the into the database. Kind of like PHP MyAdmin, but you're going to build an interface that looks good for your app, right? And so, a great example of that is we've got this users table, right? Where's it at? Right. Generally, with a users table, this is most apps that have a users table is also often going to have a let's go add a new column after ID, after email. All right, we're going to say password. We'll make this a var car. Right, fine, whatever. Safe. All right. So most users table is going to have, these three things, right? An ID, because you need to know what user they are. They're going to have, some email address or a username or something like that, and then you're going to have a password. Now, your users table is probably going to have a whole bunch of other stuff in there as well, like what are their permission level, or what is their address, what is their whatever. But the way you're going to write a form is going to be like, give me your email address and give me your password, and then when they click submit, it goes and checks to see if the password matches the password you have in the database. And so you're going to build all of your interfaces on the HTML side to simplify the user experience, because you don't want them to come in here and have to edit all these table values. You only want to let them update and control tables or columns that are user editable, right? So this is the job, right? This is the whole point of being a software engineer, is making that determination of, I need to store a whole bunch of information to make my program work. I need to let the users give me the information they need to give me. But how do I make interfaces that are really nice so that they only have to do the few things they need to do and not be bothered with all these extra details? So there's no one size fits all answer to this, Gregory, because this is what being a software engineer is all about, which is, what are you trying to build and how you want to get there for your users? Any other questions? And we'll keep playing for sure. No. Andrew, go ahead.
So I'm trying to visualize how you might create the logic to. I'm just trying to connect and piece everything together from both ends now, like taking a form, writing the logic for the form to maybe save and add it to the database.
Okay. Yeah, let's build something together real quick. We'll continue using
just to go full circle.
Yeah. All right. So we've got our index.html. It has nothing in it right now. Right. So we're gonna have to make some pages. This is gonna be the interface itself. Right. Think of our HTML. This is the front end. Right. This is what the users are interacting with. So let's just start with simple database demo. Right. Let's give ourselves a script. We know we're going to need script source equals js / db.js. Right. So we're going to have to make this, because this is an Express app, right? We're serving this from this, right? We need to put our folders that we want to access inside the templates folder. So I'm going to make a JS folder. I'm not going to worry about CSS just yet. All right. So first off, right? H1 DB examples. H1. All right. So let's make a div ID equals current users. Let's make this table actually. No, let's just do div ID equals current. Div. All right, and we're gonna go unordered list. So I'm gonna make an unordered list of our current users. So we'll say ul ID equals current users. Okay, so it's gonna be an empty ul. Right? Let's pull up in our db.js. Cool. And we'll come in here and we'll say document.add event listener DOM content loaded function. So when the document loads, we're going to do an XML HTTP request. So we'll say make XML HTTP request to /users, and then update. What was it called? Current users with user list. Okay. And then we're also going to have to do add a form to let me add a new user. Okay. So we'll tackle that next. All right. So if we load our page now, right here, right? DB examples. If we view page source, we can see we have our current users unordered list. It has nothing in it. That's perfectly fine. So let's make our XML HTTP request, right? So we'll do let XML XHR equals new XML HTTP request. Okay. We'll do XHR.onLoad this function. All right. We know. So in here we need to update our current users list with the users list. Okay. And then we need to say XHR.open, and we'll say get, and the URL is going to be users, right? Because we already made a users endpoint in here, and it should be close to correct, right? And then we'll do XHR.send. Okay, so if I run this right now, if we pull up our developer tools, we look at our network here, we can see that we made a request to users, and here's all the users that are in here. So if I wanted to, right, we can come in here and say, let content get users equals JSON.parse this.response text, right? So we're creating a JSON. We've got a JSON response from the server. We're going to turn it into an object, and then let's just loop through it, right? So we'll say for is this an array? Yeah, it's an array. So we'll do for var let I equals 0, I is less than users.length I plus plus. And we can, this is all, so we'll just do, let's give ourselves a let user list equals, right? We'll just make an empty string and we'll just add this real quick. We'll say user list equals user list plus li, let's do template strings, li, and we'll do users I first name, and then we'll do users I last name. Right. And then at the very end, once we've looped through that array that came back from the server, we will just simply say document.get element by ID, current users inner HTML equals user list. Right? So now if I load this page, right, all of our users from the database have been added to this page. We made an AJAX request behind the scenes. Our server, which is Express, and maybe it will help if we we'll do console.log page loaded sending user list. Okay, so when we run this now, right, as soon as I load this page, it's going to say page loaded sending user list, and we can see that response happening to the server. All right, see, this is what was sent back. We looped through it, we put it on the page. So now the next thing to do is let's make our form. Let's make a form in here that has those fields we care about. We don't want to let the users send an ID because this MySQL is going to send it. So we're just going to get first name, last name, and email address, and when we click a button, it's going to post it to this page, and then we'll save it in the database. So we're going to need two places here, right? A, we need this form. That's our to-do here. We're going to have to get that information and send it. And B, and there's an even easier, right? We don't have to do this in JavaScript. We can do this straight in HTML, right? So let's add some styling on this real quick. Style equals background color, BB border MPX solid black. Right. Okay, cool. And then we'll do width is 150 px. Is that good enough? Let's make it a little bit bigger. 250. Alright, I'm going to make another form. Give and equals form style equals float left width is 500 px, right? Background color, right? So we should have. Should have designed it better. Okay, let's put some stuff in here. H2, say like add new user. H2. Cool. And we'll do margin left. 10px. Right. Just give us a little spacing. Padding. Alright, so I've given myself some really ugly styling, but we can see that we've got space here for a form. So I'm going to add the form here. So we'll do form action equals, let's just call it user. And then method, we're going to do posts. I remember we were talking about the difference between get and post. Because we're creating a record on the server, it's appropriate to use post here. Okay, so we're going to say /form. And the things that we wanted to create, label for equals first name. Label for equals last name. Hate that it auto-indented for me. And label for equals email. Okay, so we need to make those 3 inputs. So we'll say input type equals text, name equals first name, ID equals first name. Okay, and then the same thing for last name and email. Okay, so last name, email. And we know that we're gonna need some spacing in here, so let's say BR. And this is the ugly, quick way to write HTML. Obviously, I do not recommend you do your code like this. Say input type equals submit. Value equals create user. Okay. So if we reload our page now, we can see we've got 3. I need to put. Forgot to add my email and first name. Okay. There we go. First name, last name, email. All right, real simple. If I put information in here right now, and I say like Eric Harrison, whatever, at whatever.com. If I click create user, it's going to submit this as a post request to /user, which our server doesn't have yet, right? We haven't written that endpoint. So that's what we need to write next, right? /user, and we need to do a post. So let's pull that up and see what happens. Right, so I'm going to close this real quick. So we've been doing app.get. Get is a get request. We're going to do app.post now. So we'll do app.post, and we'll say /user, and we'll say function rec res. Okay. Great. So when we post to this, we want it to take the information that was sent back and do something with it, right? So let's console.log. I can never remember. It's rec.params. Let's look at what parameters are being passed to us. Let's turn our server back on and just rerun this post. Okay, so create. Oh, it's running. Oh, because I didn't send anything back. So let's just do res.send. So we're just debugging, right? I could go look this up, which is what I would do if we weren't trying to figure it out together. But I think it's important to work through this kind of as if you didn't have any resources. Let's see if we can figure this out without having to need anybody. So let's do right. Create user, posted, came back, and this is empty. So rec.params, the parameters are not in here. So maybe it's rec.body. Let's see what's in this. Okay. We're going to just break down and go to Google and say express post parameters. Yeah. Oh man, it's by information like that. So rec.body.id. That doesn't sound right. Let's look at a different article. Let's say grabbing, handling form posts in Express. Okay, so yep, this is a good tutorial showing, hey, we got a form, submitting to a thing, it's got a username field. Let's try that, rec.body. Let's just see if first name is in here, and we'll test it and see if this works. So we'll restart our server real quick, come back here, and hit create. Okay, so maybe what we have to do, I noticed that both of these had another app.use directive saying express URL encoded extended true. I don't know what this means, but let's put this in here up with our other one and see if that is telling Express that it's okay to use this information. So let's try this, and we'll reload our page, post it. Okay, yeah, so when we want to handle forms with posts, we have to say that the form is URL encoded. So a lot of programming languages don't make you do this because they already understand that they're working with forms, but Express is making you put in this this line of code, extended true. And now if we did rec.body, it should be a whole object here that we can look at. So let's do that. Close down. There we go. Alright, so if I click this, yeah, we get an object here with first name, last name, email address. So, alright, we want to get those, store them in the database, and then reload the page. Right, so let's do that. So we'll say, store user information in database, and then when that is done, reload the page, right? Or just like redirect us to the main page. Right? So we can do connection.query, and we'll do insert into users values null, and then let's make this template string for us, and we'll do rec.body.firstname, comma rec.body.lastname, comma rec.body.email. Okay, I need to put quotes around all these. Alright, so insert into that, and when it's done, we say function rec res, error results, right? Because this is the MySQL's callback. So when the query has succeeded, this is what's gonna happen next, and then we'll simply say, res dot redirect, no, and we'll just go to slash. So we haven't taken a look at res.redirect, but res.redirect is another one of the response options that says, hey, instead of sending content back to the browser, let's just change the URL to another place. So we could have redirected to Google if we wanted in here, but by saying redirect to slash, it's basically telling the browser, okay, I'm done with whatever you were doing. Please go to if we had a path routed, it's going to go to index.html in our case. So let's see this happen. This should work. Right? And if we close this out, run the server. Alright, so we can see here that Eric Harrison 2, the third one, is our last option in here. If I click this create user right now, it should post it and insert the record, but it did not, which is weird. Let's have had an error in our query. So let's come in here and say if error. Let's do res.send error. And let's put this in else. And so it redirected, but didn't look like it inserted our record for whatever reason. So let's see if we have an error here in our code. First name, last name, email. Okay, cool. Or ER. Alright, let's take this out. And let's just do res.json, res.send results. Let's take a look at the results object. We're doing something wrong here. And ER. Parse error. You have an error in your SQL syntax. Check for the okay. So I wrote insert into users values null. That looks right. Let's just make sure we're right here. Oh, I forgot to put my closing parenthesis here. Good. Now this should work. We have to close our server. Cool. So now if we do this, column count doesn't match row count at row 1. Oh, because we added a password column. Dang it. So this is why it's really useful to be explicit, right? So like insert into users, we want to put in ID. Let's take out ID, so we don't have to pass null. So let's say first name, last name, email, right? Because we added that password field as an example. We forgot to include that because I forgot we put it in there. So we want to be explicit in telling them these are the columns I'm putting information in. So if we reload this now, this should all work. Right? I can put in, a little smaller, say Andrew B. Andrew. Create user. Good. And you can see Andrew shows up in the list now. Okay. And so now, I mean, you know, the next thing that jumps to mind is we probably need some kind of function to delete users as well, right? Like, or update the ones that are here, right? So maybe what I would do, let's do update first, and then let's then we'll work on delete, right? So right now we already have the form that lets me add a new user, so we did that natively. Let's add another click handler. Yep, good. So this loads it when the page loads. That's good. So let's say when I click a user, load their information in the form for editing. Okay, cool. Right, so we need this to be a linked, right? So we probably want to say ID equals user, and we'll put in $ID. Wait, users ID, right? So because we need to have that ID so we can know which record we're going to update. So we need to have that somehow. And so what we should do here, if we look at our elements now, yeah, we see user 1, 2, 3, 4, 5, 6. It skips 7 and 8 because we deleted those two when we were playing with delete. Perfect. So this is a good spot. So now, you know, I would probably choose to make these anchors, so that you know that they're clickable, right? Like a href equals, you know, whatever, do something. But I think for this case, like we can just, you know, for the sake of simplicity, let's just say document.getElement by ID. And what was the, what do we call this? Current users. Current users. So we're going to put a click event on the unordered list itself. So add event listener, click, function event. Right? So we know, how do I get access to what element I clicked on? I've asked this question 17 times.
Just
target it.
Okay, what would I write?
Event.target.
Event.target. Perfect. Now we know I added the click event handler on the owner list, right? So if I did console.log element, right? And I reload. It's not log, right? You know, I can click outside of the thing and it's still firing. So I probably need to like ignore if it's not an LI. So I would probably want to do something like, well, I don't remember what the stupid thing is. Event.target. Let's look at it like this. So if I go into event.target, I think it's like node name, right? Node name, yeah. So if, here, we'll just do this. If event.target.nodename equals li, right, then we want to do the stuff, right? So what we want to do is we need to get this, right? Because we know that this, we created those IDs. It's user underscore and then the ID number. So we need to get the let user ID equals element.id.split underscore, and then we can do the first element in that array, right? So it'll be user underscore 1, user underscore 5. We split it, so we just get the number back. All right, and then we want to make a query, another XML HTTP request, to go off and fetch the information for that specific user and return just that one record that we can fill in the form information to. So let's do that. So we'll say fetch user information and put on the form. Like we know that's what we want to do. So let's make that request first, and then let's go about writing the backend part, because that's the fun bit, right? So we'll say let xhr equals new XML HTTP request. Okay, xhr.onload function. As long as we won't log this.response text. Right? We know we want to get. Let's actually do JSON.parse, just so we can see it when it comes back from the server. Okay. xhr.open, and for this, right? So, when I'm writing APIs, there's a couple of ways to go about this, right? Whenever I'm trying to fetch groups of things, I want to have it be plural, right? So when we were writing our code here, we said users, right? Because that implies I'm going to return more than one. When I'm doing a single user, I want it to be /user. So I would often write my API to be like app.get/user, okay, and then user ID. And we haven't discussed this colon syntax, but we're going to play with it here in a second because it's really useful and powerful. All right, cool. So that's what it's going to be. And we'll just real quickly stub this out, res, and we'll just say res.json, something. True. Okay. So right now, if we do, when we run this code, user, and we'll do plus user ID. So we're saying go to /user/user ID. Now we could have just as easily said, user ID equals, but I think this syntax is quite a bit cleaner, where you're doing like user/1, user/7, rather than putting question marks and query parameters all over the place. I think this is a nicer way to write your URLs and write your routes. So to open, and then that was the second parameter. So we're going to say get, right? So open with get and send the request to user/user ID, and then we do xhr.send, which actually sends the request. So if I come over here and I load my console here, and I click on Dexter Morgan, trying to load user 6, which does a 404 not found, because we had to restart our server. So let's restart our server, and now if I click on this, it's returning that information, something true, right? So the server is responding correctly. We just have to write that information now. So let's do that. So instead of this, right? So fetch a single user record and send it back to in JSON. Okay. So connection. Right, this is our MySQL connection. Connection.query, and we'll just use select ID, first name, last name, email from users where ID equals question mark. Okay. And then, actually, let's just do it here. I don't want to introduce parameterized queries yet. Plus rec.params.user ID. Okay. So we've been playing. So with this format, this is an express specific thing. When you put in your URL colon and then a thing, this word, whatever word you put in here, becomes available to the request parameter. So it's as if you'd passed in user ID equals. Express is cool enough to know that when we put in colon user ID, it's going to come in as like /user/6, and it makes it available to us in this variable. Everyone follow along? Like, this is a super powerful thing, but we can play with this in other ways too. Anyway, let's continue on, right? So our MySQL callback is going to do error and results. Okay, and just so these are starting to get kind of long, I'm going to put this down like this, right? So the query is the first argument, and then your function is the second argument, right? And so the function, all right, let's do, because we're querying a single user, right? If I put in, if this is user 6, it's going to say select ID, first name, last name, email from users where ID equals 6. This is a real simple thing. We can just do res.json results. And we just send it back directly. It's going to be one record. Send that object back to our server. So let's just test this out. Restart our server real quick. And if I click on Andrew B, we should see, record 0 is Andrew. So I don't like that it's put in an array already. So let's fix that. So let's just say return results 0. And let's restart our server and play with it again. Right? Oh, it's perfect. Right? So every time I click on one of these things, I'm getting the server to respond back to me with the individual record already in an ID in a format that we can use. So, all right. 5 lines of code, and we have our API in the back end returning back our single individual user information. So what I would do in here, right, inside here, right, this is where we're logging out. Let's put this part, fetch user information, okay? So we fetched it. Let's put it in the form now. All right, so there's gonna be a problem, and the problem is, right, when we're storing the record in the form, right, we got 2 options. Either A, we can build a new form that is like update user. That's probably the best way. Let's do that. So what we want to do is when we click on one of these things, we want to update our current form to be an update form instead of a new user form. So let's do that first. Alright, so we have index.html. We need to give this form an ID. ID equals user form, right? So that we can make some changes to it. Then we probably want to change, ID equals user heading, right? And the reason I'm doing this, right? This heading says add new user. When I'm in here, I want to document.getElement by ID user heading inner HTML equals update user, and we'll just we'll put in the user ID plus we need to make this an object for ourselves. So let's do let user equals JSON.parse this.response text, and we'll say user.id. So that when I click on one of these links, instead of saying add new user, it will say update user 11. Right? Maybe we want to make this even nicer and put not the user ID, but like user dot first name. But we also have to update the form so that it's not, because you remember, like right now it's posting to user, which is good, but right, that's being handled by this code at post, and it's doing an insert. But we need to do an update if it's an existing user. So we probably want to first create a new element inside this so that we know, hey, we're operating on user ID 11, not user ID null, right? So that's kind of my thinking here is that, like, if we're updating a user, I need to pass along a user ID to let the backend know I'm updating a user, not creating a new one. So let's do that real quick. We created we have a user form. So document.getElement by ID user form. And we want to just .inner HTML equals, and we'll do the same thing. We just want to add a new element, right? Plus, and we'll just do input type equals hidden, name equals user ID, ID equals user ID, value equals plus user.id plus, right? So I've just simply added a new, let's put that at the top so we know what we're doing. We know we're doing this. Plus, right? So our form already exists and it has all the fields we want, but we want a new input in there that has our user ID. And so if we simply click on this now and we inspect this element, we should see, yeah, we've got a hidden element in here that's ready to go. So now, if we updated these, let's just add this information here. We'll say document.getElement by ID. Was it first name? Dot value equals user dot first name. Just copy all these, paste. Do last name, email, last name, email. Okay, so now when I click on this, all the values should show up in there, right? Like these are the fields that are in here. But we want and we want the button to say update user instead of create user, right? So we need to give this an ID as well. ID equals submit button. Right? And so I'll come in here and say document.getElement by ID submit button dot value equals update user plus user dot first name. Right, great. So if I click on Harry Morgan, yeah, update user Harry, we can see all the fields here. Everything's working great. But if I click this, it's still going to go to our app.post route, and it is going to insert those values in there. So to me, I mean, this is real simple if, right? So we can say if rec.body.user ID, okay, we are updating, else we are creating. So we can put all this stuff in this one we are creating. That code is all still good. And let's tab this in, right? And then we do the same thing for updating, right? So connection.query update users set first name equals rec.body.first name. Oh, I need to make this that kind. Okay. Last name equals rec.body.last name. And email equals rec.body.email. Where ID equals what was it? Rec.body.user ID. Cool. Oops. I have to make sure our string is correct here. Update user set first name equals the first name parameter. Last name equals the last name parameter. Email equals the email. Where ID equals that. Yep, perfect. So we need a callback for this, right? So function error results. And then we just say res dot redirect slash. Okay. So this should work. Andrew B, let's change your Andrew the Wise. Oh, I forgot to restart the server. Dang it. Okay. So let's make Andrew the Wise. Andrew the forgot to update the server. So you can see we've updated that record, right? So Eric Harrison 2, you can make this Eric Harrison 3. This can be Steve. So now we're updating, and if we just do this form without clicking a thing first, it's going to do the old behavior and just insert a record. Does everyone kind of follow along? Like, this is a very simplistic app that we've thrown together in like 20 minutes. All the old rules apply of the things that you learned over the last week or the last couple weeks, which is you're going to spend a little bit of time up front designing your app, making sure it looks nice. You're going to design all your forms, and then making it actually connect to the database is the real fun part. And you can see that it doesn't take many lines of code to do this, to make things store, to make things update in real time, when you've already got all the components in place. So once you've built a structure that is good, then it's really easy to attach functionality. It's really easy to attach data. It's really easy to store things, and that's 99% of what you'll do on a day-to-day basis. Does that answer your question of how you kind of tie all this together? Cool. Now, tomorrow we'll probably dive into some more security stuff because I've written some really bad code here. Because this makes us vulnerable to SQL injection and other kinds of problems like that, where nefarious people can come in and escape our code. So there's other techniques we need to learn about, like parameterizing our queries and things like that. But this is like a good start, and I'd really like you to. I'm gonna upload all this to GitHub, and I'd like you to play with this. We'll probably make a simple homework tomorrow for like the lab where. You create an Express app like this, and you create a database, and I don't care what you call it, but it's going to do something like this, where you're going to load a list of results, and you're going to have a form that updates those records. Okay, and then it should have like a get route and a post route and I don't care if you want to make it fancy, if you want to make it a golf app, but just starting to play with some of this stuff. Actually, you know what? I think there's probably like SQL homework to do first today. We'll continue playing with apps later this week. I don't want to give you something more complicated than we're ready for yet. But what I would think would be cool is that all of you who have been working on apps, so like Andrew with your golf app, Leah with your poker app, Estrella, now that you have a database installed in your system, and we have PHPMyAdmin, you can go in there and create tables and stuff, start creating what you think your data model will look like. Okay. It is 8:30. We've covered a lot. We're going to continue to look for ways to bring the database stuff that we're learning into the coding stuff we've also been learning, so that we're going to continue to find ways to merge these concepts together, because they, having a database without an app is kind of, I don't know why you do that, and having an app without a database, like, you need both. Any questions? Anything you want to go over more? Leah, go ahead.
Is it preference choosing between, like, if you want to use the like dashboard UI, or like using VS Code to use MySQL, or is it more common to use like VS Code for that?
What was in what sense? So, like, are you talking about this PHPMyAdmin stuff?
Yeah, exactly.
So
yeah.
This is just an interface to let you get into the database and see what the data is. I'm going to be honest with you. I've used this like 10 times in my whole life. Most of the time when I'm working with a database, and I'll just pull up a real project here. Let's see. Easy to use. trying to not show sensitive information. Hold on. Yeah, like I'll almost always. I don't know if you can see this. I'm almost always going to interact with MySQL from the command line, because I'm almost always the server is always going to be in some remote. It's hosted on Amazon. The only time I'd ever maybe use PHPMyAdmin is if I was developing locally. Maybe, but I don't know. It's just easier for me to, like, all the stuff that you can do in SQL, you can do in the command line here. So I can do, select 1+1. I mean, it's completely preferences, I guess the short answer. Whatever you feel most comfortable in. You're going to be writing SQL regardless of which tool you're in, whether it's MySQL Workbench or the command line or PHPMyAdmin. The only thing that this is going to give you is, like, this is listing all the tables for you, so you don't have to remember what they're all called. And so, like, and when you click the table, it automatically runs select star from it so that you can see information there. That's pretty useful. But go ahead, Andrew.
So are there methods in the command line to where, let's say you forget all of the names of the different tables, can you pull up a list of tables?
It's not a command in the command line, it's a SQL command. So show tables.
Okay.
If I run this is the same thing that PHPMyAdmin is doing to generate this table list over here on the left. Right? This is just a PHP program that is running a bunch of SQL commands to, like, create menus and things. So when I do show tables, it's showing files, posts, and users, because I'm in the database first DB. If I come back in here into the SQL tab and I say use MySQL, right, that's going to put me in that table or in this database, and then I can do show tables. And if I go on this, right, it's going to say, hey, MySQL return an empty, and you can see that this has now expanded because it knows I'm in that database. And when I did show tables there, it's showing me all the tables that are inside here. So this is doing nothing special that you can't do in the command line or you can't do in another program. These programs are just, they took all that SQL and made it a button click. Go ahead.
You know the like GitHub pages that we did. Would it be possible to use, like what would be the process of going from using like the server here and putting it like and using it in there?
Yeah. So GitHub Pages is a special case. That's provided by GitHub to just serve static content. So you don't have any ability to write any backend code in GitHub Pages. Next week, when we talk about deployments and we learn about, like, how to set up servers and do that kind of thing, we're probably going to use Heroku as a first example. But in the real world, I mean, what you're generally going to do is you're going to have, you're going to work for a company, and you're either going to have a dedicated server where the server is running both your web server and your database, or if you're working on a high volume website that gets thousands of hits, you're probably going to have a web server, and then you're going to have like a database server on a separate machine. So like Amazon is famous for this, where they even have like hosted databases where you just say, I need an extra large database, MySQL. They create that for you. You don't have to think about it. And your web server is just gonna you're gonna put the host name like here instead of localhost. This will be something like cx492.amazon.rds.com or whatever. And then the username and password are going to be the same, whatever the username and password is. But your database connection doesn't care where the server is. It just knows I need to connect to it. And then we can fetch data over the internet. Now, the problem is, to your question of GitHub Pages doesn't let us even write backend code. Heroku will, but we're still going to have to find a place to host our MySQL database because Heroku is not going to provide us a database engine. There are some free database engines. We were talking in week 1 of, like, why should you ever learn the command line stuff, is because most of the time, what I would do, Amazon is an excellent hosting provider. You're probably going to use it at work, but it's overkill for small projects that you're doing just for yourself. So you're probably going to end up with hosting providers like DigitalOcean, right, where you're just going to go get an entire virtual server for like $10 a month, and you're going to go in there and you're going to install MySQL. It's going to run the database, and then you're going to install Node, and you're going to run your app on that and connect to localhost of your database. Like, this is the easy mode, but in order to do this, you have to be able to navigate the command line. You have to be able to, how do I install MySQL on DigitalOcean? It's going to walk you through the steps. So there's no one size fits all because there's so many different solutions, and we're gonna explore a few of them in this class, but we cannot possibly cover the breadth of, like, I know a little bit about AWS, but there's entire professions of people who are just AWS implementation experts, and AWS has like 1,000 components in it, but everything from like hosted databases to like DNS servers to text message interfaces. Like, it's big. And then Google has their own version of cloud. Microsoft has Azure, which is their own version of cloud, and they all do different things, even though they all have the same functionality. They're going to do it in a slightly different way. So don't get bogged down in the details. It's, at the stage you're in right now, like I got started, I was just like, I need a server. And so before DigitalOcean even existed and gave us low-cost servers, in the late 90s, early 2000s, I used to pay to have a server co-located. So it was like $100 a month to get a really crappy computer with like 1 gig of RAM at some hosting facility that was connected to a T1. It's much easier now, but the techniques, as long as you understand you need a server, you need a database, you can figure it out in most of these platforms. And we'll cover Heroku. We might look at some database hosting provider options. Or we might look at, I don't want to make you guys have to go and buy stuff, right? But if you wanted to, you could get, a very small DigitalOcean server for $5 a month. Right? It's got 1 gig of RAM and 1 CPU. It's got 25 gigs of storage. That's pretty cheap. And then you can buy a domain name like leahscoolwebsite.com and point it at that IP address, and you'll be up and running. The cool thing about these providers is they scale with you. So if you build a product, and this is how like companies do things, like I don't know how much server I'm going to need. Right off the beginning, I might have like 4 users, and that's like the people on my team that are building stuff. But as soon as I get like 100 users, I can just go in there and be like, oh my gosh, I need the $40 a month version now. Upgrade me, and they'll just turn on more resources for you. It takes away a lot of the terror and fear around growth that used to exist. What other questions?
So when I disconnect from the PHP MyAdmin, are those databases still going to be there?
Yep.
Cool.
Yeah. The
Okay.
database itself, I mean, assuming there was not like you didn't close it while it was trying to do a write operation, something got corrupted. MySQL behind the scenes is smart enough to know, like, hey, when the server stops, make sure everything that it's like written to a file. And it's, I don't know what MySQL's file format looks like. They're using, we're using the InnoDB engine, and the engine tells it how to like save and store data onto the computer. It's probably in some kind of crazy binary format where like every third bit is a new field or something. I don't know, but it's actually writing to the hard drive. And then the cool thing is when you start up MySQL again, one of the things that makes most of these modern database engines so efficient is that like tables that you're accessing frequently, they're just going to be in RAM, right? So it's going to keep the table and all the information in the table in memory as much as possible, so that when you make a query, it doesn't have to go read from a file. It just says like, what is in this address, and that's why it's able to give you results in under a fraction of a second. It's because all that data is already in RAM. But when you're done, just click stop. But you'll also notice now that like, I can't view our database anymore, and then B, if I'm clicking on these things, right, like even though my server is running, right, like we're getting connection refused because the database is not responding to our app. So, cool. What else? we were talking about MySQL Workbench, right? It knows that there's a local database here. So MySQL Workbench by default, when you're just running it by itself, it's not connected to any database, but you can connect to it. And so we can even come here and see. So this is just another interface for. Don't want any of this crap. Yeah, get. So you can see here's our first DB, right? And all of our tables are there. And if you go to files, right, we can select rows, right? So this is just another tool that we can use if we want to, similar to PHPMyAdmin. And I'm pretty sure there's a Mac version of this as well. So play around with this. But this has some really cool functionality. I don't know how to get into it. So then how do you find that like cool table viewer thing?
Click on the building home thingy up there. And then go to the connectee box thing.
This
Yeah, yep. And then click on
plus sign?
the plus. Yep. And then the add diagram.
Cool.
And then here you can do all that stuff. Yeah, you have to click on one of the thingies on the side to create the table. I can't tell if it's the left or the right, but you see the little tiny like bar thingy there, or it's got the little boxes and the lines and stuff.
Sure.
Yep, go down, right there. Yeah, you can like click on that and then click on the screen, and then you can double click it on the name part. And then you can add in all that stuff that you've seen me do before.
Yeah. So if you are a more visual person, like this tool is really cool because it lets you like create your tables in this type of view type of thing, and then you can like show the relationships between records and drag lines and stuff between things. But I prefer to just write the code. But this tool has a bunch of extra features that PHPMyAdmin does not. And this tool was actually made by the MySQL company, so it's got even more support necessarily than PHPMyAdmin, which is a different group.
And then it can show you the actual connections with like lines to each box to see how they're connected.
That's pretty cool. Oh boy. I think I crashed it. Nice. Crashed it. Cool. Any other questions? Oh, cool. PHPMyAdmin has like a little designer mode too. So you can like see the table visualizations. Create relationship. So you can say, where was it? User ID to ID. You'd have to like create a foreign key relationship. That's annoying. But, real big complicated apps, this kind of visualization is really cool. I was working on a project, like 15 years ago, where we had 192 different tables, and all the tables were like 45 plus columns long. So you can get some really complex programs with just mountains and mountains of wild. So you can see that like as you start creating relationships, you can show the lines and things between them in this type of view. Some people like this type of thing, so it's important to know how to do it. Cool. Any other questions? Guys, all good? Alright, I'm gonna stop the recording.